Okay. So technically, when you get into the background implementation of list, right? So how did they implement it? They have created a class. They took one template, and this template type has been applied across the class. And whenever you instantiate this class, the type of this template has to be supplied, right? So whatever the type is provided for your template, it allows you to add only that similar type of data elements. Okay. Now they have created internally, okay, inside your list class, they have created some methods like add, remove, and count. What does add do? Add will take care of inserting new elements into your collection. What remove will do? It will take care of removing the elements. Okay. Now, if I want to create my own class, like your list, what should I do? So create your own class with your own name. Let's say public class, my list. You can give any name, my list. What should I do to make it generic, to make it type safe? I have to take a template. You can give any name, TG, anything. Ideally, we give it as T. Okay. Now what happens? Now it expects the type to be supplied at the time of your object class object creation, right? Now I can apply this anywhere. I'm going to create a method, public void add, like your list. What should be the type of the element? T element, right? In a similar way, add, remove. What does it expect? Whenever you want to remove an element from your collection, you have to supply the index of the element. Index of the element. So index is nothing but integer. Int index. And what is the count? Your count should return public int count. It should return, whenever I call this method, it should return number of elements. Let's say, for example, I am going to store this into one of my integer array, int a. Here, what should I return? I should return a dot length. Okay. So this is a skeleton. Now, if someone wants to use your component to store collection of data elements, okay, what they have to do? So they have to create instance of your class, like list. Whenever they create instance of my class, see, it is also coming like your list. It is also similar to your list, my list, and it is highlighted with less than greater than symbol. It means it is expecting the type of template to be supplied here, right? So whenever I create instance of this, I should also supply the type. obj1 is equal to new my list, right? Now you have to write the implementation of add, remove, like this. This is your own component. List might contain only 10 different functionalities. This is your component. You can add 20 different functionalities, 30 different functionalities to make it more user friendly, right? So if your component contains more functionalities than what we have in list, obviously your component will become more popular. Are you with me? So start creating your own components. And you could also do one thing. I want to do one thing. Whatever is there in list, it is already there in list. It is a free component, right? Which has been provided by Microsoft. Why should I create the same functionalities again and again? I don't want to do that. Rather, I want to inherit the functionalities of list. Let's say, for example, add, remove, count is already there. I just want to make use of them. I want to reuse those functionalities. And on top of that, I'd like to add my own functionalities. In this case, what should I do? You should inherit this list. You should inherit the list. Are you to me? Okay. So in a similar way, you can inherit n number of things. Now what it will do? This is my own class. Whatever is in list, I'm just inheriting all the properties of list. So whatever is there in list, I can reuse them. And on top of that, I can add my own functionalities. Now your thing is going to contain the combination of, it is a superset of list and your own functionalities. Right? If you know the properties of list, now when it comes to my list, this will have both list functionalities as well as your own functionalities. Alright, think like this. Here you will get a chance to play with inheritance, play with method overloading, method overriding, polymorphism. Are you getting me? Now you can write your own functionalities. Whatever you want to, you can do that to make it more reusable component. Any questions, guys?
No, sir.
Is that clear?
Yeah.
Okay.
Yes, sir.
Now, how do I create a component like hash table or a dictionary? For example, dictionary. What does it expect? See the definition here. It expects the type of two template to be supplied. It expecting two templates to be supplied from the calling environment. Why two templates? Because in dictionary, each entry of dictionary is going to be a key value pair. Always the value will be stored based on the key. So you need to supply both key and value, right? That's why you would be needing two templates. One template for the type of key and one template for type of value. Are you with me? Something like this. Dictionary, some string, comma string, obj2 is equal to new dictionary. Now, how do I create my own dictionary? Simple. Same thing. Dictionary contains some functionalities. Yeah, it is already built using some set of functionalities. You don't have to rewrite the same functions again and again. Rather, make use of these functionalities. Whatever is already there in dictionary, start reusing those functionality. On top of that, write your own functionalities. Now your class will become superset of both, right? So how do I build it? Public class, my dictionary. I'm giving the name as my, you can give any name, right? Now, this should take the type of key and value. So I'd be needing two templates because key type can be different from value type. I can give something like int comma string, string comma int. It need not be same. You can give anything. Type can be different from value, value can be different from type. That's why I need two templates. T, I'm just giving it as T key. You can give any name for your template, not only T. You could also give your name, T value. Right? Now I would like to inherit the existing properties of dictionary. Dictionary, T key, T value. Right? Your dictionary also comes with add, remove, and count. On top of that, you can write your own functionalities. Dictionary doesn't contain sorting functionality. Your dictionary doesn't contain sorting functionality. Now, my dictionary is your component. So whatever is there in dictionary, try to get them inherited into your class and write your own functionality like sorting. Sorting by ascending, sorting by descending. Are you getting me? So like this, you can write your own functionalities to make it more powerful, more reusable. Okay. If you start doing like this, then you will become expert in C#. If you just learn the concept as is, you cannot do anything. Are you with me? Every programming language would provide some basic things to start with your programming. So whatever is required to write your program, those things are being provided by your programming language. And with the help of those things, you have to start creating your own components. Then only you will become expert in programming language, not only C#, in any programming language. Does it make sense?
Okay. Yes, sir.
Okay. So please do create these components. Okay.
Okay.
Right. Next, so next concept. Exception handling. This is very, very important concept. Exception handling. When it comes to real-time environment, for example, let us assume that you are working on an application called trading application. Trading application. Have you ever done trading in any trading application? Like buying shares, selling shares, doing intraday? Do you have any idea about it?
Yes, sir.
Right? There, let us assume that you are working on that kind of application and production. Right? Lakhs of peoples, millions of peoples would keep the trigger. Right? They would buy some shares and keep the trigger for selling. Someone would sell, then buy. Right? It can be vice versa. You can buy first, then sell. You can sell first, then buy. Right? So people would keep triggers on their shares to get the trigger automatically whenever that reaches some particular point. So they'll be making thousands of transactions, millions of transactions. In 1 second, anything can happen. Okay. The window starts at 9:30 in the morning and ends at 3:30 in the evening. Between this duration, some millions of transactions will be happening. Buy, sell, buy, sell, buy. And people will be doing the trading on some crores of rupees also, some people. If you're working on that kind of application on the production system, if that goes down for 30 minutes, what would be the impact? Let's say you bought some shares, intraday shares. Intraday means those things should be triggered on the same day. If you bought something, should be sold on the same day. If you already sold something, should be bought on the same day. If you want to carry forward, then there will be some restrictions, some other rules will be applied. Right? If let us assume that you're working on that kind of application, if that kind of application goes down for 30 minutes, what would be the impact? Let's say you bought intraday shares of 1 crore rupees. If you're doing trading on index changes from millisecond to millisecond, second to second. In 1 second, it might go up, it might go down. Within second, you can make crores of rupees. Within second, you could also lose crores of rupees. There may be chances of losing your money or gaining your money. Right? So during that window, that period, if your application goes down for 30 minutes, what would be the impact? You feel tensed because you don't even know what is happening, because you already bought 1 crore shares. What would be the impact? You may lose your money, you may gain more money. Right? If you lose your money, you will get impacted. Anything can happen. So when it comes to real-time applications, there will be some agreements between client and service provider. When it comes to applications will be categorized into 3 categories: silver, bronze, and gold. Silver, bronze, and gold. We classify the application types into 3 categories. If the impact is very low, for example, let's say application is down for 1 hour, still there is no impact. That kind of application comes under silver category. I don't know, for example, your Yahoo Mail, Gmail, right? If that application goes down for 2 minutes or 30 minutes, 1 hour, there may be impact, but not that much. The impact is very low. You could also check your emails maybe after 1 hour, 2 hours. Impact is low. That kind of applications comes under silver category. Next, bronze. Bronze. If the impact is little high, medium, that kind of application comes under, for example, you're booking tickets online for flight, right? Your flight is at 11 p.m. in the evening. Now you wanted to book the ticket, but the site is down. What happens? It would definitely impact 2 minutes. Yes, can you hear me?
Yes, sir.
మధ్య మధ్యలో డ్రాప్ అవుతుంది ఇవాళ ఏదో ప్రాబ్లం ఉన్నట్టుంది ఇంటర్నెట్. ఓకే. Okay, so if the impact is little high, that would consider as medium level risk. That comes under bronze. And if the impact is very high, for example, your share market application, not even 30 minutes, if that application goes down for at least 1 minute, there will be a huge impact. Lot of transactions will get impacted. People keep on calling the customer center. They keep on scolding because you don't know, right, what is happening in the share market. That should not even go down for 1 minute. The impact will be very high. So that kind of applications will be considered as gold. If you're working on gold type of applications like your share market, if you're working on the production system, let us assume that your application started throwing some issues. Now what has to be done? You don't have time. You have to get that fixed within seconds, within minutes, not even hours. There will be serious SLAs between client and service provider. As I said, there will be some there will be some windows, for example, in case of silver application, if the application is down, in how many hours it has to be fixed? There will be a SLA, service level agreement. There will be a serious turnaround time, the response time, the resolution time. These will be on the paper. If silver kind of application goes down on the live environment, what would be the resolution time? 1 hour, 2 hour, 3 hour. If that exceeds the resolution time, agreed timelines, the service provider has to pay some penalties back to the client. In case of silver level applications, sometimes it can be 10 hours, 12 hours. In some cases, it will be 6 hours, 7 hours. That depends upon the mutual understanding between service provider and client. In case of branch, it will be hardly 1 to 2 hours. In case of gold, it will be hardly 1 to 2 minutes. Less than an hour, not more than that. Again, in bronze, in gold also, there will be several different types of applications. For example, your ATM. ATM also comes under gold level application, your banking application. The time that differs, resolution time differs from application to application in case of gold also. But when it comes to this trading kind of applications, it will be very less. Let us assume that you are working on share market application. Now your application is down. You have to get it up and running. What has to be done? You found a defect. It is throwing. So for some reason, for some unknown reason, the website has stopped working. Your share market application has stopped working. Now, who will fix that issue? Whoever is working on the production system should take care of fixing that issue immediately. If you're working on the production system, right, you have to take care of it. You have to get that fixed immediately within minutes. How do you do that? Your application contains millions lines of code. Your application contains millions of lines of code. How do you trace it and fix it? Are you getting me? So you have to use your due diligence to identify the root cause and to get that fixed immediately. Are you getting me? So what has to be done? You have to step into your application, go back to your application, start debugging it, identify the root cause. If you start debugging it, there can be millions of instructions. There can be millions of instructions, right? If I start looking into all instructions one by one, how much time is going to be consumed? Right? So the debugging process itself would consume a lot of time. You would spend in the process of debugging each and every instruction, you would spend a lot of time to identify the root cause. Are you getting me? So that leads to a problem. That leads to a problem. This problem has to be overcome. If I start looking into all lines one by one, if there are millions of instructions, that would consume a lot of time to identify the root cause. It should not be like that. Rather, I'd like to keep my entire code into some block. Whenever any exception occurs, I want to redirect the control. I want to tell the control, hey, if some error occurs, where to go? I want to define two blocks. I want to keep my entire code in one block, and I want to track the error details from another block. I want to tell the system, if any error occurs in this block, directly go to this block. If the control comes to this block, from there, I can take the control and read the error information. And I'll get to know what is happening in my code. And based on that, I can take the respective action. But is that possible? No. By default, whenever any exception, any error occurs in your code, by default, the control will be taken by your system. The exception will be, the error will be handled by your system. Once it is handled by the system, it throws some system error message. It contains some technical information. You may or may not understand what is happening inside your code. By default, all exceptions will be handled by your system. If that is handled by your system, it throws some technical message. It may or may not be useful for you to understand what is happening in your code, for you to identify the root cause of that issue. But what should I do? If something has to be traced immediately, when I need to find the root cause immediately, what has to be done? So as I said, if you don't do anything, if you don't take the control over your code, by default, system will take the control over your code. By default, all exceptions will be handled by your system. But if I want to take the control over my code, if I want to use my control to read those error details, if I want to drive that execution process, if I want to catch the errors, what should I do? I have to handle these exceptions explicitly from my code. If you don't want that to go to system, if don't want, that has to be handled by your system. What has to be done? You have to write your own program explicitly. You have to take the control over and you have to run that process. You have to handle the exceptions from your code. You should tell the system from where it has to be handled. If you can do that, you'll be having full control over your code. So whenever any exception occurs, now you know if any exception occurs, where it will go. You can directly go to that place, keep a breakpoint, and catch that defect, catch that error, read that information, take the appropriate action. Any questions, guys, so far?
No, sir.
Okay. So if you want to take the control over the exceptions that are happening in your code, so that exception handling mechanism has to be implemented explicitly by the developer. So how do I implement this? There are unstructured and structured exception handling. In the legacy system, we used to handle all exceptions using unstructured. But in the modern systems, we have a well-structured mechanism available. You have to make use of that, the structured exception handling mechanism, to handle exceptions properly in your code. So what is that? So that is going to be your try and catch. We can implement this using try and catch blocks. Try and catch blocks. Whenever you want to handle your exceptions explicitly, when you want to take the control over and identify the root cause within a short span of time, then that has to be implemented explicitly. So how do I implement it? If you want to handle your exceptions from your code, and that has to be implemented explicitly using try and catch block. Why do we need try and catch block? So your entire logic, whatever the code that you have written, that complete piece has to be placed inside try block. And why do we need catch? For every try block, there should be a corresponding catch block. For every try block, there should be a corresponding catch block. Why? So if any error occurs, where is my code? Your entire code is placed inside try block. If any exception occurs in my code, immediately control will go to catch a block. If the control is here, it means something happened in try. If everything goes fine, it will never go to catch. If everything goes fine, if everything got executed successfully, it will not go to catch. It will go to catch a block if and only if the error occurs in your try block. The control came to catch means, oh, something happened in try. Some exception happened in try. What try would do? It returns. We have a base class called exception. We have a base class called exception. By default, all exceptions will be handled by this. The information of all exceptions will be stored into this class. So once it comes to your cache, just make use of this class to read the exception details. So read the exception details and take the appropriate action. Now in my try, I can write millions of code. The error can occur anywhere, but finally it will go to cache. Once it comes to cache, okay, now I'll get to know that, oh, something happened in try. Now in cache, using this base class of exceptions, that is the exception class. By default, the error information of everything will be stored into exception. This is the base class. Using this class, I'll be able to read the information of that corresponding error. Any questions, guys?
No, sir.
Next, what is finally? What is finally? So here, we have a concept of daemon thread. Daemon thread. What is a daemon thread? A thread which runs in the background. A thread which runs in the background is called as daemon thread. In your program, you'll be writing millions of instructions. Once your program gets executed, once your execution gets completed and result is produced, what has to be done? Where it will be executing? Whatever you are doing your mission, everything will get executed in your main memory, in your RAM. In your RAM. Are you to me? So if the RAM size is very high, it will be running very faster. If the RAM size is low, I mean, the main memory size. It will slow down your process because whenever you open any application in your system, it will get loaded into your main memory RAM. Once it becomes full, if you try to open another application, what happens? It will slow down the process. Are you with me? So that's why always you should have enough space in your RAM. If the space is empty, your application will be running very faster. Okay. So whenever you open any application in your machine, first that will get loaded into your RAM. It will be running from your RAM. If you're storing something, if you're doing something, everything will get loaded into RAM. Are you with me? Okay. Here we have written thousands of instructions. Now when I press start, what happens? It will compile your code and execute this. And before that, your entire code will be loaded into RAM. It will occupy some memory because it has to store your data into, it has to create some variables. Your data has to be stored, right? It has to allocate that much amount of memory to process your request. That's why first your thread, your complete main program will be considered as one thread. It will be loaded into main memory. It would occupy some memory, right? Here you written thousands of instructions. Okay, you have successfully executed your program. Once that execution gets completed, now what has to be done? Whatever is loaded into main memory, that has to be cleaned. That has to be cleared for memory to allow another application to occupy that space. If that is not clear, what happens? If you keep on executing, it will become full. The main memory will become full if you do not clear these things. Whenever it is loaded next time, again it will occupy some more memory. What happens? As you keep on executing it, as you keep on loading other applications, what happens? It will keep on filling your main memory. At some point, your main memory will become full. There will be no space to execute other applications. So that's why what has to be done? As long as the execution gets finished. So once your execution gets finished, so what has to be done? Immediately. So whatever is loaded into that, whatever the resources that are loaded into your main memory should be cleared immediately. As soon as the execution is completed, this has to be cleared from your main memory. So who will take care of clearing those things? Your daemon thread. We have a class called GC, garbage collector. You need to know this concept, man. Garbage collector. And there is another thing called dispose or finalize. GC is a class. It comes with a set of methods. One of them is gc.collect. GC is a garbage collector. This is called a daemon thread. Whenever your application starts, in the background, this thread will also be started automatically. What is the responsibility of this thread? It keeps looking for unused objects. If that finds any unused object, immediately it will take care of removing that from your main memory so that we can free up some space. You can clear some space, right? It just, whenever your application starts, immediately one thread will be started. That is called daemon thread. A thread which runs in the background is called as daemon thread. And this won't be visible. It runs in the background of your application. What is the responsibility of this? It just keeps looking for unused objects in the memory. If there is any unused object identified, it will take care of removing that. Are you getting me? Any questions, guys?
No, sir.
So gc.collect will take care of removing unused objects, but it will take care of removing only one object at a time, not all objects at a time. It will take care of, it is very effective, but little slow. It will take care of removing only one object at a time, not all objects at one go. And if there are any third-party DLLs referred, if your application process is using any third-party DLLs, that should also be disposed. That should also be cleared from your memory. Are you with me? So in case of that, it is very slow. It doesn't dispose all at a time. It will take care of disposing them one by one. But whereas we have another method called dispose and final. You can take the control and you can dispose all objects at a time based on your requirement. By default, this thread starts automatically in the background. It will take care of removing unused objects. It will be running throughout the lifetime of your application. Once your application gets closed, this background thread will get destroyed. This will be running till your application is running. Once your application gets closed, then only it will be destroyed from main memory. But if you feel like, for example, in the previous case, in try black, I'm writing 1,000 lines of code. Out of 1,000 lines, 10 lines of code are accessing some third-party libraries. Here I'm creating too many objects to interact with the third-party libraries. Anyway, once your application gets executed, execution gets completed, your GC collect will take care of destroying them. But it doesn't destroy all this at a time. It will take care of destroying them one by one. So that might take more time to get all this destroyed from your main memory. Right? So here, this is one of your class. Like this, you'll be having thousands of classes in the real-time application. You know that here you have created too many objects. Why should I wait for GC to destroy this? It might take some time. Why don't you dispose it immediately? As soon as your execution gets completed, why don't you get them destroyed immediately? That way you can reduce some burden on GC and you can free up some space immediately. That would allow other applications to run very faster. Are you reading me? So if you want to take the control over disposing the objects, then you can make use of these methods, dispose and finalize. These will take care of disposing the complete black at a time. But how do I do that? So when it comes to try comes with two blacks, catch and finally. When the control will go to catch, if the exception is not occurred, then it will never go to catch. It will go to catch if and only if any error occurs in your try black, right? So no error occurred. It got executed successfully. Will it go to catch? No, it will not go to catch, but it will go to finally black. Every time it will not go to catch A. It will go to catch A if and only if any exception occurs in try. But every time it will go to finally. Every time it will go to finally black. So here we are creating too many objects. If you want to dispose them explicitly from your code, you can take the control over and dispose them from your finally black. Because anyway, every time it will go to finally. When it will go to finally, whatever is placed inside try, once this execution gets finished, then only it will go to finally black. Once it comes to finally, it means, okay, the execution got finished. Now what I have to do? I should dispose everything from the main memory. So whatever I have created in try, now I can dispose everything from the main memory. So that's why you would also be needing finally black. You can write try and catch without finally. Finally is not mandatory, it is optional, but catch is mandatory. If you are going to write any try black, there should be a corresponding catch black. Catch is mandatory. And finally is optional. If you want to dispose something explicitly, you can write finally black. Otherwise, you can skip it. If you don't have a requirement of disposing something or driving something explicitly, okay, then finally is not required. But catch is mandatory. If I do not write catch, it throws the error. Any questions, guys?
No, sir.
Okay, now you understood the concept of your daemon thread, GC collector, the responsibility of garbage collector, right? What is the difference between these two? your garbage collector and dispose, finalize. It removes, you don't have to call it explicitly. Whenever your application starts, Debian thread starts automatically, that is your garbage collector. It will be running till your application is running. Right? It will be active till your application is running. And what is the responsibility of this? It just keep on looking for unused objects till your application is running. It will be there throughout the lifetime of the application. Right? But the difference between these two is it will dispose only one object at a time. But these will take care of disposing the unit of code, set up things at a time. So compared to GC collect, these are very faster. That is only difference. Okay. Next, let's implement this. Let's see how to handle your exceptions. For example, I'm going to define two variables, int a. Let's discuss simple example, int a, b, and c. Now, I'm going to write a logic. Here, what is my logic? I need to ask user to enter these numbers, a and b. I should perform some division operation and store the quotient into c. Store the quotient into c. That is what my operation. Right? Now, I want to implement exception handling. If something happens in my code, that should be handled from my code only. I want to take the control over and read the execution, read the exception details. So how do I do that? If you want to implement the exception handling explicitly, you have to make use of try catch. So your entire logic should be placed inside try. So whatever the action to be performed, that complete action has to be placed inside try. And as I said, there should be a corresponding catch block. Here it takes one parameter, exception ex. As I said, exception is a base class. By default, all exceptions information will be stored into this. It is a generic class. Now what happens? Now I can write any action inside try. Whenever any error occurs inside try, immediately it will go to catch block, corresponding catch block. So within my programming environment, I can write n number of tries, n number of catch blocks. Now, here I'm going to write my logic, console dot write line. Please enter a. Read it. A is equal to convert dot 2 into 32 of console dot read line. Please enter B. Okay. Now what happens? First, let's see without try catch. I'm just commenting this. Okay, I'm just commenting this. Now I'm going to perform some operation. C is equal to A divided by B. Console dot write line. Result is C. Okay. Let's enter this. Please enter A 3 B 0. What happened? We did not implement any exception handling explicitly. If you do not take the control, by default, the control will be taken by the system. By default, your exception will be handled by the system. If that is handled by the system, it throws some technical message which you may or may not understand. End user cannot understand it. What is this? System dot divided by, if you throw this exception to end user, can he understand this message? What does it mean? He cannot understand it. This is little bit better. In some cases, it will be sending something like x into 0 into c into b. What does he think? It doesn't know what is happening inside in the system. Because this is a technical exception. Right? So if you want to handle these exceptions, so because sometimes we need to educate the user. He might have entered a wrong input, but you have to educate them. You should tell them. So why this error happened? A is entered, A is equal to 3, B is equal to 0. Technically, if 0 by something is going to be 0. If something by 0, it will enter into infinity loop. That's it saying attempted to divide it by 0. But he cannot understand it. If you throw this technical exception to the end user, what does he think about it? He cannot understand what is happening. He doesn't know what to do. So to avoid these kind of issues, what has to be done? This exception should be handled by your code. You have to take the control, read this exception, and throw some user-friendly message to the end user. Tell him, hey, the B value should not be 0. It should be greater than 0. Please enter non-zero value. Then you can understand, oh, who I entered 0, I should not enter 0. Any user-friendly message. Read me. Now let's see. To avoid this, what has to be done? I should keep this code inside try black. Now I want to implement my own exception handling. I want to handle this exception from my code. I don't want to give the control to system. Place your entire action inside try. If any error occurs, immediately control will go to catch a black. Let's keep a breakpoint here. One breakpoint here. Please enter A 3, B 0. Now we are going to perform the operation. Okay. What happened? Immediately it jumped into catch a black because some exception occurred here. Here you can see. Some exception occurred here. It contains the complete details of the exception, but it will mean some technical terms. You can stack, trace, and everything. Okay. So when it comes to real-time applications, what has to be done? Your entire action has to be placed inside a try. If any exception occurs, it will go to catch a. From here, take the control and throw some user-friendly message to the end user. Here, I want to display some message like console dot right line denominator should not be 0. Please enter a value greater than 0. Now what I'm doing? I'm sending some user-friendly message, right? Three, 0. What happened? Denominator should not be 0. Please enter a value greater than 0. Earlier, what happened? The application got stuck in the middle. But here, it did not stop your execution process. Earlier, it has interrupted my execution process, right? But here, it is not interrupting your execution process. We took the control and we throw some error message. Execution has been continued and we have educated the user. We have thrown some user-friendly message to the end user. Any questions, guys?
No.
Okay, so in the real time, if you're debugging some application, what you should do? Just keep a breakpoint here, keep one breakpoint in the catch a block. If some exception occurs anywhere, there can be 1,000 lines of code. The exception can occur anywhere. If the exception occurs anywhere in this entire action, immediately it will go to corresponding catch a block. If you keep a breakpoint here, it will definitely come to catch block. From here, read these exception details. You'll get to know what is happening over there. Okay. And as I said, finally is an optional block. If you want, you can write finally. For example, here I'm creating objects for some third-party components like list or array list. Array list. Obj is equal to new array list. Right? Now I'm using this array list in my process. Not only array list, I'm going to define other things also like hash table, dictionary. Okay. Now what happens? Immediately an object will be created. It would occupy some space, right? So once my process completed, once your execution gets completed successfully, what should I do? I should not wait for garbage collector to dispose this object. Rather, why don't you dispose it immediately? Why do you want to wait for others to do it? If you do it, it will be removed immediately from the memory. You can free up some space immediately, right? So that kind of things can be handled from finally black. Finally, you can also write finally. A try can have n number of catch blacks, but it should have only one finally black. Here what I can do? I can write obj dot dispose, obj dot. Okay, so there is a process for this. Okay, from here I can take the control and I can dispose all these objects. Okay, for example, system dot. I'll show you one of them. Data dot SQL client. SQL data adapter obj is equal to SQL data adapter. You could also implement your own finalize method. But some methods already provided with dispose and finalize. There are few methods. We'll give you that. Okay. If you're going to create some third-party objects, okay, those are already provided with these methods, dispose and finalize. Okay. So from here, not only disposing your objects, you can do anything. If something has to be done after completing your execution, that control can be taken from your finally black. Okay. And you could also implement your own dispose class, own finalize class. For example, array list is not implemented dispose and finalize, right? As I said, if you want to dispose it explicitly, we have a interface called iDisposable interface. Just derive that, implement iDisposable and write your own dispose and finalize method. Okay, so that we will see later in the Windows application. It's part of our syllabus. Okay, anything guys? Any questions? No? Guys, can you hear me? Hello? Sridhar, can you hear me? Sridhar? Guys, can you hear me? Sridhar and Dantu, can you hear me? Sridhar, can you hear me? Guys, so here, for example, we have a third-party DL called system.data.sql client. It has a class called SQL command. Okay. So now I'm going to use this command in this process. Once this gets finished, now I need to dispose it. How do I dispose it? Here I can call. It has already, your SQL command class has already implemented a dispose method. You just need to call that dot dispose. It will take care of disposing this object immediately from your memory. Any questions?